Hello everybody, this is Professor Jing. This week we're going to talk about linear regression. This is a really fun topic. Let's dive straight in. Here is this week's learning objectives. First, we will talk about simple linear regression. So we're going to talk about bivariate data, scatter plot, and correlation. And also, we're going to define the assumption for linear regression model and how you can fit in the model. And then we will talk about multiple linear regression. In this section, we will also talk about the assumption. So in order to build a model, you have to meet the model assumption and also how you can fit the model as well as how you do the variable selection, because that is something really important for multiple linear regression. And in the last section, we're going to talk about model performance evaluation. We're going to look at residuals, and we're going to compare different models and try to evaluate model and see if which model is the champion model, and also and try to assessing the fit of linear regression models. So what is bivariate data? So bivariate data is consisting of two variables, often in search in an association. Professionals always want to know how two numeric variables are related. For example, is there a relationship between the grade on the quiz a student takes and the grades on the final? Is there a relationship? What is the relationship? And how strong is it? So when we look at the bivariate data, we need to decide if possible, does changing one variable seems lead to changing to the other? Response variable, what is also called y or dependent variable or predictive variable, measures or recorded the outcome of the study. An exploratory variable is also called x, independent variable, or predictor variable that explains the change in response variables. So as you can see in the notes, the bivariate analysis is referring to the analysis of exact two variables. Of course, we also have univariate analysis or multivariate analysis. Depends on the number of variables in the study. When considering the relationship between two quantitative variables, we often start with a graph, specifically scatter plot. And then we look at an overall pattern and deviation from the pattern. Then use the numeric description of the data and overall pattern. For example, like correlation, coefficient of the determination. And lastly, we consider to build a mathematical model like a regression model. When looking at a scatter plot, you always want to note shape, trend, and strengths. Those are three important things that you always want to keep your eye on first. For the shape, although we may see other shapes in the scatter plot, at this point, we are only interested in applying these ideas when we see the linear pattern. The linear patterns are quite common. The linear relationship is strong if the points are close to the straight line, except in the case of a horizontal line where there's no relationship. If we think that the point show a linear relationship, we should like to draw a line of the scatter plot. This line will later be calculated through a process called linear regression. However, we only calculate a linear line when one of the variables helps to explain and predict the other. If we do see a linear pattern, what sort of relationship is there? A positive trend it seems when increasing of x also increase y. On the other hand, a negative trend it seems increasing x appear causing y to decrease. So in other words, there are three scenarios here. First, high values of one variable occurs when high value of the other variable. Second, low volumes of one variable occurring when the low volume of the other variable. And the third, high volume of one variable occurring when the low volume of the other variable, right? So let's talk about strings. At this point, we can think about the strings of a relationship as how tightly do the points on scatter plot fit the linear pattern. The stronger relationship has points clustered together closely, while the weaker one points are more spread out. The strength of a relationship is not always appeared in the scatter plot, but we will see the numerical measure of this in the future. Let's talk about correlation analysis here. So the correlation coefficient R was developed by Carl Pearson in the early 1900s. Is the numerical measure that provides a measure of strength and direction of linear association between the independent variable x and dependent variable y. If you suspect a linear relationship between x and y, then R can measures how strong the linear relation is. So the value of this R is, it tells us that the value is always between -1 and +1. And the size of the correlation R indicate that the strength of linear relationship between x and y. The value of R close to -1 or to +1 indicate the stronger linear relationship between x and y. If R is equal to 0, there's likely no linear relationship. It is important to view the scatter plot, however, because the data that exhibit a curved or horizontal pattern may have a correlation of 0. If R is equal to 1, there is perfect positive correlation. If R is equal to -1, then there is also perfect negative correlation. In both of these cases, all the original data points lay on the straight line. Of course, in the real world, it will not generally happen. Let's look at an example how you calculate the Pearson coefficient by hand. So in the given example, I have x, that is the age, and then I also have y variable, that is the glucose level. So first thing you want to do is you want to use x multiplied by y, and you want to also square x and also square y to get the value. And in the second step, you want to sum each column, and then in the third step, you want to plug it into the formula. Once you plug into the formula, and you will get that R is equal to 0.5298. So I want you to pause here and then just refresh all the steps and see if you can get the same result. Now let's look at the assumptions for simple linear regression model. So when you consider the relationship between the two quantitative variables, the first assumption is the linearity, right? So that is the relationship between variable x and y, and they have to be linear. To check this assumption, right, you need to plot x and y on a scatter plot and see if there is a linear relation. So second, we want to check the independence of error. So we have to make sure there is no relationship between the residual and the x variable. And in other words, y is independent of arrows. To check this assumption, we need to examine it by plotting a scatter plot again of using a residual versus the fit. So for those who doesn't know what residual is basically is the difference between the observed value and the predicted value. As you can see in the bottom, the footnote, I'm listing that formula for you. So the correlation of residual and fizz should be approximately equal to 0. In other words, there should not look like a relationship between the two variables, right? The next assumption is normality of arrows, right? The residual must be approximately normally distributed. That's the third, assumptions. And the last assumption here is the equal variance. So the variance of residuals is the same for all values of x, right? We check this assumption again by examining the scatter plot of residual versus the fit, right? The variance of residual should be the same across all the value of x's. If the plot shows a pattern, then the variance is not consistent, then this, assumption has not been met. So if any of those assumptions are not being met, then we cannot perform the simple linear regression, right? So what is regression analysis or linear regression analysis? So when you think about doing this modeling, right, you try to use the independent variable, try to use that to explain the dependent variable, which is using x explain the variable y, right? So basically, if you plot the relationship between the two variables, if you look at the chart, it should be a straight line, right? Since they have linear relationship. If you take the variable x and y and try to fit it in the model using SPSS or other statistical softwares, it will give you the value for A, for B, and also for the arrow term. Once you have those values, and if you have one of the value of x, and it will basically give you the value of y, and your y is your predicted value, and your x is the independent or exploratory variable, right? So it's just there is such a linear relationship. You can use this function to make your prediction. Let's look at an example, right? I'm giving you a very simple data set that only has two variables, x and y, and I'm giving you the value, right? So the first step you take is to plot the data on the scatter plot, and as you can see on the chart on the left hand side, right? You can see that it's formed almost a straight line. And then by performing the simple linear regression, you get the line that best fit, right? So it basically in the second step, that green line will give you the best fit that has the minimal residual, which is the difference between the predicted value and the observed value, right? Once you take the data and fit in the model, you will get the value for A, B, and the arrow term, right? So let's assume you get the value for A is 1, and B is 1, and the arrow term is 1. So then you want to make a prediction for x equal to 1. Then you plug in the function, right? We have the linear function there, and then you will just get that the result is going to be 3. So 3 is your y value. which is come from 1 plus 1 times 1 plus 1. So this is a very simple explanation and demonstration of how you build this model. And next, we will talk about more complicated model, which is the multiple linear regression model. So that will be in the next part.